Okay, back for another video lesson on how to complete these Regents Common Core geometry exam questions. All right, so number 13. Okay, so we're going to perform a dilation, but in this case, the center is not the origin. We cannot just multiply the coordinates in this case. So there's a few ways to do this. We're looking at a scale factor of 2. I usually call that K. Okay. What we're going to end up doing is we're going to double the distance. So we'll take it, whatever the distance from the center of dilation, and we're going to multiply it by 2. Now, we'll do this for x and y. So if you look, here's our center of dilation right here. So, you know, the image of C is going to be somewhere along this line. Okay? So what's going to happen is the center of dilation, the pre-image, and the image all are collinear along the same line. Okay? Likewise for B. Okay, we're going to follow this path. And if the scale factor was negative, we'd continue this way. Going this way. But it's not. So we're going to be somewhere on this line for C prime, somewhere on this line for B prime. So the distance, if we look at the change in x from A to B, it's 1. We're simply going to double that. So we're going to go over to 2. The distance up and down is 1. We're going to double that from A. We're going to go down to here. So it's right there. That's going to be B prime. Okay? So the change in x, that's going to be 2. The change in y is going to be 2. That's for B. For C, all right, the original change in x is going to be 1. Double that. Okay, so the change in x is going to be 2. Now the change in y is going to be a little different. It's right now it's 3. Double that. We're going to go to 6. So watch. We start at A, go this way 2, and up and down 6. Right there. So that's where C prime will land. All right, so B prime landed on, looks like 5, 2. From, there's our origin. And it looks like C prime landed at 1, negative 2. So let's find that choice. For 13, it looks like, yeah, right there. All right. Let's see. All right, sine of angle A. So if we look at our acronym here, sine is going to define the ratio of the opposite side to the hypotenuse. So if this is our angle, if this is our acute angle right here, A, these are the sides opposite, and these are the hypotenuse right here. Okay, so we either have to have BC over AB, or we have to have ED over AD. So we'll just look for that. I don't see any EDs on top. BC over L, right there. Okay, so we're looking at choice 3. Okay. All right, we're going to have to sketch a diagram for 15. It's going to take a few tries here. These problems, what I try to teach my students is read them through a couple of times before you even try to draw a diagram. But then after you read them a few times, draw the diagram. So let's make sure we read it first. In circle O, that means the center is going to be O. Secants ADB and AEC are drawn from external point A. Okay, DBE and C are on the circle. Okay, so read it a second time. All right, I'm starting to get the picture in my head. I'm going to put O in the center. All right, there's an external point A. Oops. And There's a secant. Let's see, A to D to B. Try to keep that order. And then AEC. All right. So that's got to be E, and this has got to be C. And if AD is 8, that's the exterior of that. AE is 6. Oh boy. EC is 12 more than BD. Here's the only way we can do that. We're going to have to call that X. And whatever that is, whatever BD is, this is going to be 12 more. Okay. So if we do this all algebraically, all right, we use in our, we've shortcutted a little bit for our students. Rather than trying to get the similar triangles and setting up the proportion, we've shortcut these a little bit for them. We use kind of a, I don't know, not a theorem necessarily, but whole times exterior equals whole times exterior. That simply means this whole secant times its outside part should equal this whole secant times its outside part. All right. And there's a way to prove that. You see this triangle here, ADC. It's similar to triangle AEB. And we could set up the whole corresponding sides are proportional. And then the cross products end up giving us this formula. So we've shortcut a little bit. So let's just go through and let's assume you know that. The whole thing on AB is x plus 8. Okay? And the outside part is 8. Now the whole thing on AC is x plus 18, and the outside part is 6. Now, we could distribute. There's probably quicker ways, but let's just do this to try not to leave anybody behind. I think that's 108. Okay, so we're going to subtract 6x, and subtract 64. All right, so we've got 2x, and that's equal to 42. X is 21. Let's make sure my math is right on this. I'll do it in my head. Oops, sorry, made a mistake here. Let's see. Yeah, that is not 42. That is 44. So that's 22. And let's see, we're just looking for the length of BD. BD is just x, so we're good. BD is 22. All right. There you go. All right, parallelogram. Okay. These problems, these are just knowing the properties of quadrilaterals. And the way I speak of these is, I talk about upgrading them. All right, a quadrilateral has no special features. And as soon as you get something such as the opposite sides are parallel, you upgrade it from a quadrilateral to a parallelogram. Okay, what we're saying right now is we have a parallelogram and we want to upgrade it to a rectangle. That's essentially what we're saying. Take the properties of a parallelogram and give it something special so that we can upgrade to a rectangle. Which of these choices would upgrade a parallelogram to a rectangle? The diagonals bisecting each other? No, because parallelograms already have that feature. Diagonals intersect at right angles? That is going to be a rhombus feature. We don't need that for a rectangle. And opposite angles are congruent. Parallelograms already have that. So what's the one? It's diagonals are congruent. Now this is a little tricky. The fact is we already have a parallelogram. Once we upgrade the diagonals being congruent, that's a rectangle. So why is that important to start with a parallelogram? Well, diagonals congruent could be an isosceles trapezoid, but we upgraded it to a parallelogram, so diagonals congruent from a parallelogram makes it a rectangle. Okay, All right, so this is about rotational symmetry is what we talk about. Rotational symmetry. Basically, you're looking at the idea of you have a figure and you want it to map onto itself, but this is a little tricky because you know, when you have, let's say, a regular decagon, I can't draw that. Let me just, for a second, let me just draw something like a hexagon. Okay, so this is the concept. Whoops, I don't know what just happened. Okay, so say you have, this is just a hexagon here. The concept of mapping onto itself with rotation is we're going to spin this. A is not going to land back at A. Okay, A is going to move and let's say hit B, right? Well, it has a point. A is going to match another point on the original figure. So you're not going to have any new points hanging out there. There's going to be no new outline drawn. That's essentially when you want to carry onto itself, map onto itself. Again, your points aren't going to make it back to their original locations. Your points are going to make it to another point that is on, that's already outlined in the figure. Okay, so let's get rid of the hexagon because that could be a little confusing. All right, what we are going to do is we're going to talk about a decagon. A decagon has 10 sides, and I like to think of it as a rotational symmetry is look at consider a circle. Okay, there's essentially 10 equally spaced dots around the circle. Now, to map it onto itself, and there's 10 equally spaced dots, okay, what we would have to do is, remember, there's a circle of 360 degrees. Okay, if there's 10 equally spaced dots, there's 36 degrees between each dot. All right, that's not a choice. You're looking up here, that's not a choice. So it's another trick here. Basically, you're going to look at which one of these is divisible by 36. Okay, so 54 divided by 36, it's not going to be a nice round whole number. Okay, basically what we're looking at is going to be choice 4. 36 times what equals 250. So then what we need in there is a 7. 36 times 7 is 252. So you could make 7 moves, okay, and then A would land back on to another point that's on the decagon. Okay, so that was the trick on this one. None of these other ones are divisible by 36. Okay, for the next one, we got to get a circle. X and y are both squared. We've got to get that equation into center radius form. We're looking at this. This is center radius form. All right. Now, this creates a little bit of a problem. So we're going to have to do what's called completing the square. We're all set with x. That's nice. But we need to add something in so that we can eventually turn that into a, a parentheses squared like this is. Okay? So we're going to come back to that. Keep the plus 1 and equals 0. But then whatever you add right here, you should also add over there. So what are we going to need? Well, the way I show my students is I cut that in half. Okay, so you're going to get a minus 3 there. But when you have negative 3 squared, it's positive 9. So basically, try to understand that these 3 together are equivalent to y minus 3 quantity squared. Now, whatever you do to the left, you've got to do to the right to keep that balance. Just bring these down along, right? The plus 1, 0 plus 9 is 9. We're going to subtract 1, and we have x squared plus y minus 3 squared equals 8. All right, so the center is 0 and 3. Okay, it's always the opposite of whatever this is. So that when you plug in a 3 for y, that goes to 0. All right, the radius, well, that's going to be the square root of that. Now, if we want to simplify square root of 8, kind of break that down into its multiples. Square root of 4 is regular 2. So we've got a radius of 2 square roots of 2. Looks like we want choice 1. All right. Let's see. Oh, great. For this one, we're going to need some graph. All right, so brought some graph paper over. Now, little trick here. What they gave us, if you read these coordinates, it's A, B, C, D. And when they give us A and C, it skips a letter. They're essentially telling us AC is a diagonal. So you've got to understand that concept. There's A. There's C. Okay? They're already telling us it's a parallelogram. All right? What we need to know to upgrade it and prove that it's a rhombus, okay, we need to make sure that we find BD, and we have to make sure that the slope, we're going to get perpendicular, basically. We need perpendicular diagonals. If you can get perpendicular diagonals from a parallelogram, that upgrades to a rhombus. Now again, remember, we started with a parallelogram, so we know that all those other features, such as the diagonals bisect each other, it's all done. We just need the diagonals to be perpendicular. So what we need is, we need the slopes to be negative reciprocals. Make sure we're not using the wrong terminology here. I hear opposite reciprocals all the time. Make sure we say negative reciprocals. Change the sign and flip. So what I did was, right here, if you look, the slope first of AC, right? You've got a rise of 1, 2, 3, 4, 5, 6, and a run of 2. Rise over run, and it looks like it's moving down, right? If you move left to right, it's going down, so that is going to throw a negative in there. Let's take out a 2. So it's negative 3/2. So now the slope of BD, okay, it's got to be perpendicular to that. So if it turns out to being 2/3 or something equivalent to 2/3, right? Change the sign and flip. That's what we're going to need. Okay, and it's not looking good for us there. They want us to use 1/3. Whoops, I did not reduce correctly. Never mind. That's why. My fault. Okay, never mind. So that was, I forgot to take out the 2. Negative 3 over 1, that's positive 1/3 when we take the negative reciprocal of that. So yes, we do have that choice right there. Sorry about that. So that's the one we want, choice 3. All right, point Q is on MN. All right, we're going to want graph again on this one. Okay, so here we go. We're going to graph, where is this, 3, 5? That is M. That's N. Okay. And we have to partition a segment. And if you want a ratio of 2 to 3, that means 5 equal parts. So that's what we're looking for here. So what I would do is I would figure out how far over is the change in x, right? It's 1, 2, 3, 4. Let's get this right. I think it's 5, yeah. So change in x is 5. Change in y is 1, 2, 3, 4. Looks like 10 is the change in y. All right. So basically what we're going to do is, if the change in x is 5, we're going to take 5 divided by 5 to get 1. All right. So each point is going to be over 1, and divided by 5 is 2. So it looks like it's going to be over 1 down 2. That's going to be from M to there is 1 equal part. Over 1 down 2, over 1 down 2. All right, if you look at this now, we have just split this into 5 equal parts. Okay? And we want M to Q to be 2 of those parts. So that must be where Q is. There's 2 parts. And then there's the 3 right there. Okay, so where is that location? 1, 2, 3, 4, 5, 1. Looks like 5, 1. Okay. All right. Let's get back over here. All right, I got tricked on this one when I first did it. Okay. What you've got to be careful of is this is 60 degrees in here, but they want the area of the shaded region. So the first thing I did was I subtracted 60 degrees to go to 300 degrees. So from here to here is 300 degrees. Now, there's a few ways to do this. S equals theta r for arc length, right? Oh, no, area, sorry. So we want area. Area of a circle, this is how I do it. I get the full circle first, pi r squared. Okay, so r is 8, so I get 64 pi. Now for these area of a sector problems, there's a couple ways to do it. Proportions work great, but if you just understand the idea of we're not going around the whole circle, we're only going over, 300 degrees out of 360. So 64 pi is the full circle. But if we're only going 300 out of 360, okay, we can end up multiplying by that fraction. Okay. Now, in your calculator, type in 64 times 300 over 360. Leave the pi because all your answers are in terms of pi. Okay? Let the calculator, because, the inspires will do this, the calculator will reduce this fraction for us, which makes this a lot easier to do. So go ahead and type that in. Let the inspire simplify the fraction for you, and you get, looks like 160 over 3. Don't forget we have pi in there as well. So 160 pi over 3 is what we want. Okay, a couple more. Wow. All right, another graphing. We're going to need that. So, all right, I'll go grab graph. All right, when you get on the final, just make sure you use your scrap graph paper to your advantage on these types of problems. All right, great. -5, 12. Oh, the center is the origin. Okay, you're going to need more graph paper than what I've got. Oh, I see it. All right. All right, basically you're going to go like this. -5. So you're going to be up here. Here's the basic idea. If you consider this triangle right here, what you have is this is the radius of the circle. Okay, try to imagine us, taking your compass tool and attempting, right, to draw that circle. I know that's awful, but best I can do freehand. Okay. Yeah. So this is basically what you're looking at. You could write the equation of this circle because the center, because the center is 0, 0, right? If this is your center radius format, center 0, 0, you're going to have that. Now we're going to find r from this, okay? Pythagorean theorem. So 5 squared plus 12 squared equals r squared. And so we can just put that right there. So that's r squared. No reason, no sense in square rooting and then squaring again. Now, basically what we're looking for is we want to take a set of coordinates. This isn't the right answer. I shouldn't have circled it. I'm going to show you what I'm going to do, though. I'm going to take the coordinates. I'm going to plug them in. So I'm going to try x equals 10, y equals 3. So let's check. Is 10 squared plus 3 squared, does that equal 169? No, that's 109. So that one's out. So I can go through this process with each of these. 12, that's not going to work. That's too much. I could try 11. What's 11 squared plus 2 root 12 squared? Be really careful here. 121. That's going to be 4 times 48. Yep, that's the one. And the question mark is, does that equal 169? And it does. So this is our, right here, this is the one we want. So that's one of the, one of the trickier problems that I've seen for this type of standard. So, all right, pretty good. A plane, let's go to 23. A plane intersects a hexagonal prism. Oh boy. Okay, so I'm going to attempt to draw a hexagonal prism. Not going to be easy at all. I'm going to have to draw it this way, which isn't as nice, but not great. But you get the idea. All right, which two-dimensional figure is the cross-section of the plane intersecting the prism? Oh, you got to be perpendicular to the base. Now, the way I drew it, the base is actually the front hexagon. Okay, the hexagonal prism, that's defining what the base is. If you go perpendicular to that base, okay, try thinking of slicing like this. And then as you open it up, what shape or what two-dimensional shape are you looking at? And it should be a rectangle if you go perpendicular, okay? Obviously, if we go at an angle, you're going to get like a trapezoid or something like that. If we had a pyramid, you went perpendicular to the base, you might get a triangle. All right. If we went parallel to the base, we'd get another hexagon. But perpendicular to the base, open it up, you're going to get a rectangle. Okay. It's just spatial reasoning. You have to imagine what's going to happen. Not easy to do. All right. Last one for this video lesson. Yeah. Shape of a cone. Water cup. Okay. So it's a shape of a cone. Height of 4 inches. Maximum diameter of 3 inches. Half its height. Okay. Half of its height. Interesting. I'm going to fill it up halfway. Okay. Halfway would make this 2 inches. So from here to here is 2 inches. And let's see, the radius. Okay, we got to get a little cross section of this. All right, let's just look at a cross section of it. The radius here at the top is 1.5. Halfway down, right, would be half of that. So this cone will have a radius of 0.75, half of 1.5. Volume of the water in the cup. So forget all this up here. Forget that. You're going to have volume equals 1/3 pi r squared h. We had to modify the r. The r is going to be 0.75, and the h is going to be 2. So go ahead and let your calc. And let's see, I get 1.171. It's as close as we can get to choice 1. All right, that wraps up the part 1s for this exam. Hopefully this has helped.